Hi guys, and thank you for joining me for another session. And in this session, we're going to look at a console application we built using a game 5 in a row. And in this one, we're going to make it so that we can play against the computer. So there's a couple of ways to do this. You could do it using a random operation. So when a user makes a move, you randomly pick a slot and then you put the marker over there. But that's not very interesting because you'll have a higher win rate because it, selecting random slots is not going to be as intelligent. Or you could use the Minimax or Minmax, depending on how you heard the algorithm. And in this algorithm, it goes through the board and tries to figure out what's the best move for the computer to make, and then it will return with the move that we think is going to be the best and use that for the slot. Now, there is a different ways of doing this, actually creating an AI using ML.NET or some other system, but in this session, we'll just concentrate on the min-max. So before we get started, I have my when any in a row game console in here. So let's get a little bit familiarized with what we have. So if we run the game, it's actually gonna fail because if you were to go to GitHub and get this code, the code that was uploaded was in version 5, and I actually have the latest. So I'm gonna go ahead into the property section and update my project to be .NET 7. And let's go ahead and save this and run the program. So now we're presented by dialog, and in this dialog we're going to choose the number of rows that we want for our game. I'm going to go ahead and just use the 3 plus the winning in a row, which is going to also be 3. So basically we're doing tic tac toe. And here now you're getting options for player 1 to make a move, selecting 1 through 9. But we're not going to use the numbers 1 through 9. This is an error because we are doing this based on the row and column. So it's going to be column 1 or row 1, and then you'll say column 1. So if we go ahead and enter that, we get a marker for player 1, and then now we're ready for player 2. And then we can also make a marker. But what we want to do is make the second player to be an AI. So that way it can make the move for us. The computer would make it. And then everything else should work exactly as is. So the way the game was built, you have the UI, which is the console. So everything is going to be in the program. Then we have the game result. This is where the game will use this to return if it was a valid move, if not, what the error message was. And then the actual game engine, where all the code is for having our tic-tac-toe inside of this. So that's basically what the program is doing, and we are to introduce this min-max algorithm within our game. Whenever you come into any kind of a problem like this, first thing what you want to do is you want to break it down. Don't go full blast into understanding the min-max or minimax algorithm and trying to figure out where to implement this. So what we need to do is we need to prepare our game for when you're gonna have the computer do the move versus against another player you're gonna work with. So where would you do this? Well, we have our main loop, which is over here. Actually, this loop decides the size of the board and the winning and stuff. So once that's done, then we have the main loop where the game logic is going to be. So basically, we're just going to get the next player. We're going to display the board, and then we setting up the game result that we're going to be using. And then we keep looping and go from player to player for making a move. Now, this loop is only done when the user is making moves, because it is possible that the user will select an invalid selection. Like, let's say if it's player 1, you have already moved in position row 1 and column 1, and you try to choose the same slot basically, or using the player 2 slot, and basically we want to show a message saying that the move was invalid, and then we give a message about making another selection. So we just want to keep looping until the correct move is made. With that said, so now we have identified and worked with the game. Now, when you are keep moving, what we also want to do is we want to make sure that this is a valid move. So this is fine in here, except on the second loop, which is the main loop of the game, we want to continue checking to see if the game status is 0. If it's 0, it means that we still have moves to make. But if it's 1 or 2, then we know that the game either was won or there was a draw. And then we want to exit. So we only do this if there's moves left to do. And then once there's no moves to make, we just display the heads-up display, clear everything. So we want to redraw the board, and then we check to see if it's a winner or if it's a draw. So that's pretty much what the game is. Now, to break this down, first thing we need to do is identify if you're playing with a second player, this works. Now, where would you put the condition if it's going to be a computer move? I'm not going to code anything, but let's take a look and see where would you do that. So here you're selecting to say, hey, make the move, and then you read the console, and then you actually make the move. So this is for a player, but what we need to do is we need to have this so that where it'll be an if and else condition. So if it's a human, we go into doing this. If it's a AI, then we're going to do something else, right? So the very first thing you do is you just put an if condition. So for now, just say true, and then you will have the else. And you're going to go ahead and copy this. So if it's a human, we want to put that in there, and then if it's else, we'll have it to where AI moves, right? But we want to keep this making a move the same, and because we want to reuse these variables. So what we need to do is take these variables out, okay, and we want to put it outside of the if condition, and we're just going to go ahead and remove the initialization for it, because by default it'll be initialized to 0. You can set it as -1 if you want to. We're not. Now here we got an error, and what we need to do is basically set this up so that we're not initializing, because we've already initialized this. Now the game will continue to work because this is being set as true, and then the AI moves over here. So that was the first step, right? So what is the second step? Do we actually go and write the moves? We do not. We want to continue working with the game. So what we need to do is to figure out who is making the move. Right now, when we are going to the game engine, we're saying get the next player, and we're passing the current player value. It returns the next player, but we don't know if this current player or the next player is going to be an AI or if it's going to be a human. So how do you do that? Well, we need to create a class. And that class basically is going to identify our player. So in this one, we're going to say any NA row player. Okay, and I'm going to make mine public. You can have yours as internal. So the next thing is to go ahead and figure out what things we want to put in here. So I'm going to copy and paste, and then I'm going to go through what I just pasted and kind of go over all of the properties in that. Okay, so here we go. Now we have 3 properties, and then we have a constructor. And of course here we have an error because this it's not understanding what this type is. But let's go ahead and um, implement this now. What basically what we are doing here is this property is identifying if a player is a human being or if it's an AI. And to do that, what we need to do is we need to implement an enum. And so we're going to put it right here above the class because we want to keep this in the same namespace. And we're just going to call this enum player. And then it's going to be none, human, or AI. So when you're generating this class, you basically have to pass the marker, the player ID, and if it's going to be a human or AI. So you could actually have a scenario where you're going to have the AI play against the AI, right? But for now, we're going to keep it simple. We're just going to have a human and an AI going against each other. So what about the play marker? This is going to be the X or the O. You don't necessarily have to have this. You could keep this as static where player 1 is an X or player 2 is an O or vice versa. I put this in here so that later on if you want to kind of change this, you could. Then you can have, for example, now a player ID. We need to know the player and their ID. You could even have the, like, for example, player name and stuff, but we need the ID and it has to be an integer value. And the reason for that is because we have this current player, so when we are actually displaying the heads-up display, we need to know if it's player 1 or player 2. If you had modified this where you had the player's name, then you can actually also do that, saying the player and then the name is ready to make the move or and whatnot. But for now, we're just going to keep this simple, so these are options for you. So now that we have this class, what would be the next thing that we're going to do? So the next step is now to go to our program, and we need to go to the very top over here and figure out and set up our players basically. So we have here this loop that's going to set up the board. We now need to have something that's going to go ahead and set up our players. And what we're going to do is put a little comment here and just say set up players. So now I'm going to go ahead and copy paste some code again, but we are going to go over what this code is and how it's going to be used. So here we're having the code pasted, but we are actually getting an error. We're getting an error because we need to have the using statement for this, and now it's working. So we have an array, and in this array we're going to have 2 players. All right, so we're just going to have that. Next, what we're going to do is we're going to give some instructions to the person that is going to be playing to say, if you're going to play with a computer or you're going to play against another player. So here, if they entered 1, because we're going to instruct them to press 1. If it's not a 1, then it'll be against another player. If 1 is you going against the computer. So we check here for this if condition. If the condition is 1, then we'll go ahead and say if you want to start first or you want the computer to start. So again, if they press 1, then it'll be the computer's turn. And if not, then we'll set up the human player. And as you can see, we have the method here that says set up players. And then if it's an else, then player 1 will start with an X marker and player 2 will start with an O. Which will be just normal human players that we're going to be setting up. So with that said, let's go ahead and implement the setup players. So let's go ahead and come down over here. And right before we do the markers, we're going to go ahead and implement that code. Now in this code, we have the implementation that we're going to be using. And then we're going to pass the array of players, and then we're going to pass player 1 and player 2. And then we're going to statically set the indexer of the players array if it's going to be player 1 or player 2. So now the code is working and it's functioning. And the next thing is, now that we are in here, we could put that if condition here. But let's go ahead and take a look and see what this is going to look like. None of the implementation there, so it doesn't matter. So now we're going to be setting the board. Let's do 3 in a row win. And now we see the new message. If we want to play against the computer, we're going to say yes. And if we want to start first, and if you enter 1, let's actually go to where the game is going to be played. So right about here, put a break point and put 1 in here again. And if we come up over here and look at our players array, and you notice now that we have 2 of them. So the first one is human, and then the second one is an AI, and that's an O. Great. So that's all set. Let's go ahead and figure out the if implementation. We're going to be using the players array and how to implement that into our game. All right, so let's go ahead and figure out what we need to do in order for this to work. Now here we're getting this integer value, and that's telling us which player that needs to make the move. In here we're also initializing this player. So what we need to do is actually change this so that it is not a int, and this is actually a player. And then this over here, we're gonna have our players. I believe we call it game players. And we want to have the index 0. And this, of course, is not going to be player because that's an enum. So this should be our any in a row player. There we go. So now we've got our current player is always going to be index 0. And how do we actually fix this? What we need to do is get this current player and have the player ID. Okay, but we haven't set that player ID yet. And not only that, now this is coming back as saying that the current player is what it's returning is an int, but we have this any in a row. So what we need to do is go back here and let's copy that. What we need is this, because this is returning an integer value, we need to figure out how this integer value is going to work with our array. Well, this is always going to return either a 1 or a 2 depending on which player is supposed to go to. So we need to get our array and have that value to be 1 or a 2. So we're going to go ahead and give our array, and then this is going to be the integer value for the indexer. But our indexer is going to be 0 base, so we should always do -1. All right, so we got that set up, but now we have an issue where we are saying heads up display, and now we need to pass it an integer value again. So here we just can say set the player ID, and that should fix the issue on that, right? The next thing what we need to do is now set the if condition. So the current player, we can say if the current player dot equals, and we said this was going to be the human, so we're going to say if this is human, then we're going to go ahead and give him the options to select. If not, then we want the AI to make the move. So now we are getting to the part where we need to code for this. So right off the bat, what would you need to do for this to actually work? So here also on the make a move, we're getting an issue where it's expecting to be the current player and it is not. So for now, let's go ahead and comment this out and make this to be player ID, but we'll fix it so that this is not an issue. The other thing is we're getting errors on this. We're saying it's unassigned because even though this is going to be initialized as 0, it's expecting us to actually set that. So now it's working. And the reason I was doing that is because of the if and else statement. Because now it was always true, we knew that we're going to be initialized. And now that we have the if condition with this value, it may not always go into this, and that's why it had that. So what we need to do now is let's copy this, and then we'll delete some of those. So we need to delete this because that's going to be an AI, right? There we go. So now we need to have two values, so one for the row, one for the column. So we need some kind of a method that's going to give us these two values. So how would you do this? Well, we can say game engine dot give me best move, for example. Or actually, let's do get best move. And then we're going to send the current player that player ID into it. And this will return us now two values. And we're going to do that by having an integer value of best row, best row, and also we're going to have another one called end, and this one going to be best column. And then we're going to use this. That's going to be the row, and then this is going to be the column. Now we don't have this method, so we're going to have to go and define that. We also have to make some changes to make a move so that it actually is expecting our player rather than the actual ID. And you get to see why we're doing that in a minute. So we don't have this method in here, so that's going to be our next thing, to identify how to do that. You may not have seen two values coming out of a method, and this is basically a tuple that I'm using. And so that's how I'm able to pass two values. It's a basically a type that's being passed, and this is a way to code it in C#. If you're interested in it, just go ahead and do a quick Google. You'll see it. And maybe in a later tutorial, I'll explain a little bit more in depth into what it is. But for now, just know that this method is going to return two values, and now we're using those two values as our rows and columns. And then the computer is going to be sending us that, the AI, and then on the game engine we make a move. All right. So let's go ahead and figure out the get best move, where we can actually use the Minimax. So let's go ahead and generate this method. And let's go ahead and for now we'll just return just 0, 0. So just this method is working, but we'll come back and we'll fix this, and we'll go ahead and make this one public. So now we have this method functional, and if we run our program, so we do have an error. Let's go take a look at the error message and see. Okay, so here we need to do the player ID. Let's go ahead and run this. Okay, the program is actually executing. Let's go ahead and take out the breakpoint. So now we have our board and everything is functioning. If we were to actually iterate through, we would actually go into our method where the AI is being called. So let's just go ahead and go to the AI part and put a breakpoint, but we won't complete anything. So we'll just choose, and now you can see that as soon as the player moved, we're now on player 2, which is basically the AI, and we need to make a move for the player. So here is where we need to figure out how to get the best move for the AI. Now, there is the method we talked about, randomizing. We can just randomly pick an empty spot in here, and then, but again, that's not going to be very intelligent. So what would be another way of doing this? If I was to ask you how to break down this problem, how would you go about it without understanding min-max or any other algorithms to know how to figure this out and not also be using the randomization? So one way to do this is to actually look at this board and say, okay, we'll go ahead and loop through each row and each column. And if the row is empty, then we'll go ahead and make a marker. So here, you could say, it's AI's turn, so we make a 0, or excuse me, an O. And then on the next one, we would iterate and say, okay, now the user, player 1, will go, so we'll basically simulate the game. And we'll continue doing this until there's a winning move. When there's a winning move, then we need to figure out who won. Was it the AI? Was it the player? And so once we detect that, then we can go ahead and score all the moves. So we can say that if the AI goes here and the player goes here and the AI and the player, AI and the player, and now the player 2 won, then that's not a good move to make over here. So we need to figure out how to score this. So for now, to keep things a little bit more simple, let's just go ahead and write the method inside of the best move to where we're going to iterate through all the rows and all the columns to simulate the move between the AI and the player. And then we also need to be able to put the board back the way it was. Okay, so that's what we're going to do inside of the get best move. And then from here, then we'll figure out how to do the min-max algorithm. So, but for now, let's just do the looping that we need to do. So we need to do 2 loops, right? So the first loop is going to be the rows. We'll just keep this like this for now, but we'll come back and fix this. And then we're going to need another loop, and let's make this J. And then this one going to be the columns that we need to, oops, the rows of columns that we need to go through. And then we need to check to see if not, if empty, then we need to place player marker. Now, the first time you came in here is going to be the AI, but then we need to advance it for the next round to be the next player, right? So, but let's just get this to work, and then we'll figure out the rest. Okay, so now let's go ahead and fix this loop so we can actually work on this. Now what we need to do is we need to have the game board. And what I'm going to do is the game engine. There's a couple of things in here. It actually has a game board. And let's see if we have a, yep, and then it's being passed as a public. So what we're going to do is go into our method actually. So let's go back. So we're going to use that game board property, and then we're going to say get length. This is how you get the rows and the column. So, and then for instead of saying I, because we know this is going to be the rows that we're going to be iterating, so let's just call this row, and it's going to be row. There we go. And then for this one, it's going to be column. So let's actually fix this as well. So this is going to be the columns. And then here, we're going to use the same game board get linked, but this time we want the column, so this will be 1. Okay, so now we're iterating through this, and we're going to now check to see if the game board is, and let's make this row, and this should be column, right? And we're going to check to see if this is empty. So when we initialize the game, we initialize it with zeros, and that's why we're looking for that. Otherwise, the game would have either a 1 or a 2 where the player mark was. So this part is set up. And so now if it's not, what we need to do, we need to get the player marker in there, right? So we'll just go back to the game board, and we're going to pick the row and column. And now we need to place the marker. So the current player, in this one we actually call it player ID. And so that's basically what we're going to set for that. Okay, so now this is going to set this. Now what we need to do is we need to be able to figure out, we need to do a scoring in here. Okay, so we haven't talked about how to do this scoring yet. We'll come back and do that. The next thing we need to do is, let's say we do score it and we figure out if it's a good move or a bad move. Then the next thing we need to do is we need to actually reset this value that we put to where it was, right? So we're going to go back and set it to 0. So we're going to undo what we did, because all we're doing is we're simulating. You could actually take the game board and clone it, and then that way you can actually go through it and you don't have to worry about cleaning it. But for now, we'll just reuse the same game board that we have. And then once we reset it, whatever score that we got from here, we are going to check to see if good or bad, right? Or we could say min or max, but we'll come back to that in a second. Okay. So now what we need is we need a little bit of some values, and the first value is going to be an int, and this is going to be let's call this best best move, I think, best value, right? And we're going to initialize this as an int min value. Okay, and then we're going to need the int. We're going to call this best row, and let's initialize this as -1, and then create an int best column and initialize it as -1. So this best value is going to be scored against whatever we get back here, and we'll explain this in a second. So hopefully this logic is a little bit clear as far as what we're doing. And then the next thing we want to do is we're going to take the best row, and what we're going to be passing back, and the best column. Right. So now we have the skeleton of what we need to do for this method. Now inside of this, how do you do the scoring? How do you figure out you know, the value being good or bad? Well, this is where we actually need the min-max algorithm to come and help us with that, right? Because we want to know is it the minimum score or is it the maximum score, right? So, and here we're going to create another value. Let's call this int, and we're going to call this the move value. And then we're going to, let's call this Minimax Minimax algorithm. And this is going to take, for example, a depth. Because if the first time that we're going into it, it's going to be a 0. And then what we need is we need the next player, right? So here, what we need to do is we need to take this current player and figure out what the next player is going to be. So let's go to get next player, and we're going to pass it the player ID. And this should give us the next player. So we don't have the min-max algorithm created. We will go ahead and just create a generic version of it, and we'll come back to that. So the next thing we need to do is we need to figure out the move that the min-max algorithm does. Is it better than the best value that we have? And we do that by just putting a little if condition here. And we're going to say is move value. Oops. So the move value versus the best value. And what we're going to do is if the value is if the best value is less than our move value, then we need to reset that so that our best value is going to be our move value. And we're going to also remember the actual rows, right? So we're going to use the best row and we're going to use the best column. Now, incidentally, you notice that I was not typing anything and everything was being displayed for me. There's this extension here, the IntelliCode completion that is doing all of that for me. It's just basically an AI that goes through and looks at the code, and then based on the code, it predicts what needs to happen, and that's how I'm getting those completions. So basically, you can go to the Visual Studio Marketplace and then search for the IntelliCode and click install, or you can just either use Bing or Google to search for it, and then you can install the IntelliCode. Okay, so now let's go to the min-max algorithm and figure out what we need to do for this. So this is actually not V1. Let's actually call this depth. And then this one is going to be the current player, right? And now it also expects a value to be passed. So let's just right now, let's just create an int and call this best value, and use this to return so that we don't see any errors. So of course it says it's not initialized, and let's just do that. So there we go. Now the first thing is that when you come inside of this, the min-max algorithm is going to work very similar to the get best move with minor differences. So we are going to be iterating through the game board rows and columns, and we are going to check to see if it's 0, and we are going to update it with the player, and then we're actually going to call ourselves recursively, and then of course we're also going to then zero out the game board, but then we're going to figure out the best value. So instead of doing this if condition, the only difference is that we're going to do is figure out the best value and then return the best value for that. So so let's go ahead and copy this and bring it over here, and let's actually put this right between this. Okay. So we call, okay, so we have this player ID. Let's change it back to player ID so it'll make a little bit more sense. There we go. And then for depth, we're going to go and put this depth, and then we're going to say +1. Okay. So the first time that we called from the get move was 0. We're just going to keep incremented so that we know how deep this algorithm is going to go. The next thing is we're going to delete this, and we're going to score the move. Okay. So how do we score the move? Well, let's just take the best value that we have, and it's going to be equals to the player ID, and then we're checking to see if the player is an AI or not. So here, how do we know if the player is AI? Well, the thing is that we need to pass, instead of passing the player ID, we actually need to be able to pass the player object, basically. Any in a row player, so that'll be the current player, and then from here you could actually then use the player ID, which would give you the correct marker, and then you can also take this and go here and get the player ID. That would get us the next player, but the thing is that here we're passing, so we change the signature, so we can't really get the next player. What we need to do is make a new method that says get opponent and passing the current player. Okay, so let's go ahead and create this guy. And then for the best value, let's actually change that. And we'll come back and fix all of these as well since the game is calling that. So now we're going to say the current player. If the current player is equal to player.ai, then what we're going to do is we're going to do a little bit of math. And we're going to say that math.max, and we're going to take the best value and between the move value, and if not, then we want to do math.min, and we want the best. So we want to know the minimum and the maximum between these, and that's what we're going to set for the best player. So this, of course, has to be the player because that is going to be the enum. So that's what we got over here. There is some things we need to do because how do you define that this best value is a best value? Well, if we had won something, right? So we need to check to see if there is a winner as the minute we come into the min-max algorithm. So we need to check to see if, so now we're going to need a is winner, and his winner is going to be the player.ai. And if it is AI, then let's return a number, and I'm just going to use 10. You could use 1, you could use 100 or whatever, but there would be a base value that we have to set. And then we're going to also do the same thing for the human. So if it's human, then we want to do -10. So we want the minimum or we want the maximum. So the maximum would be the AI, the minimum would be the human. We also want to check to see if the board is full. Now, the reason we check the board is full is that if it was a draw, basically, if there was no winners, then the board is full, which means nobody won. And in that case, we want to return 0, right? So it's going to be somewhere between these two values. So let's go ahead and create that method, and let's go ahead and create this method. Okay, so actually I'm going to copy this for loop because we're gonna need it. Let's go inside of this. We also need to actually fix the get opponent, so let's actually fix the get opponent and then come back and fix this. And the way we fix this is we're gonna say return, and we're going to return the, go to the game constructor, and in here we can say any inner row player players, and let's go ahead, create and assign a field. So now we have the players. So this might work, but I think what we can do also is do a for each. Instead of the game board, it'll be the players. And we check to see if the current player, that player, is not equal to player dot player. And we'll go ahead and do a return on it. And we can actually make this any inner row player. It's not the best. It will be next player. And I'm going to say next player is equal to player. And we'll break out of this. And we can say return next player. But we can also simplify this as well. We can also convert this to link. But what I want to do is, we could have just had the return in here as well. That would work, but the thing is that with the way the method is gonna work, because it knows it's a for each loop, you're still gonna need to have this next player. So that's why I'm assigning it here and then breaking out of the loop and then having it go here. We only have two players in here, so you could code it any way you want to. I'm just gonna do it this way. Not that saying that this is the best way to do it, but this is just one of the ways, and that's how you're gonna get the opponent. So if now we go back to this, that should work for us, so that we are getting the correct opponent. We still have to now go into the min-max in order to figure that out. And of course, so now the next thing was that we're gonna do is the is winner. So the is winner is going to have the same logic as these guys, because we're going to go through the game board and we're going to figure out who the winner is. So we're going to say return false. And instead of the if condition here, we're not going to check for empty. We're going to check if the rows are, so now of course we need to have the player here. So we're going to say player. So we're going to say if the player, let's actually convert this to an int. So that's the player, and we're going to say and is game winner row column. Oh, I think we're reusing the name. So instead of saying is game winner, let's actually convert this to is winner. And then go to this guy. So this actually requires the game board. What we can do is actually, we could pass the game board so that it wouldn't complain, which will be the current game board. Uh, but technically, we could have fixed it so that it should have used the internal, so you don't have to pass the game board, but you can. So if that is matching, then we go into return true. So that's how we can define that there was a winner versus there is no winner, which will be false. That is if the AI won. So here we're saying that the AI win or the human based on the player, we pass it. And here we're converting it because this is a enum, it's a 0, 1, and 2. So that's how we can figure it out. Let's see. So now let's do the is full. So is full is going to have the same logic with the difference of checking the board value. So we'll just do the same thing, except that the game board is going to check to see if it is all zeros or not. Right? So this is how we will find out if there's any moves left to do. So for this one, then we're going to say false, because if it's 0, then we are going to return to say false, that it is not full. If we are down here, then we know that we didn't have any empties, and so we're going to set it to true. Okay. So let's go back to here, and let's change this so it's not game winner. And let's change this so it's not human and is full. There we go. Let's compile this to make sure this is working. So we do have a few errors. Let's go back to see what the first error is. So here it's asking that we need to pass it the array of the players, so which is the game players over here, right? And then let's go to the second one. Yeah, so this will be get opponent. And then so this one is gonna be any in a row player. We'll call this player. And let's fix that. Okay, let's go ahead and build a solution. I'm sure there's going to be one more. Yep, so which is going to be in here. So we're not going to pass the ID. We're going to actually pass the current player. Let's build this. Okay, the build succeeded. Everything is good. So now let's go back to here. Let's go to min-max algorithm. And I believe if everything is done correctly, this should work. So let's go run our game. Let's try 3, 3. I'm going to say against the AI, I want to be the first player. So let's just do 1, 1. And then the move became position 2. So now back to player 1. So the player 1 will say row 1, position column 3. So let's do row 2, column 3. And let's do 2, 2, and this one, let's say row 3, and that's going to be column 2. The game is a draw. 3 in a row, player 1. I want to start first, so I'm going to go 2, 2, and so this time we want to go to row 3 and column 1. So now this time, let's see if the AI is going to know how to win. We'll just do 2, 1. Okay, so here it says this is incorrect, so let's actually go and fix this because the AI won. So we have to go in our okay, so the current player, not player, oops, not player ID. There we go. So now that should work. So that's pretty much how you do the find out the best move and then call the min-max algorithm. Now, this was the way I explained it is not the way you probably, if you Google it, you don't see the way the min-max algorithm is explained. But I'm hoping that the code made sense so that when you do actually go look at the min-max or minimax and how this algorithm actually works, so that way it'll make more sense about how to take that algorithm and understand what the code is actually doing in here. So just briefly, if you look, we're saying that if it's an AI and it's going to win, you can score it higher. But if it's a human, your opponent, then we're going to have it as lower. So this is the maximum value. This is the minimum value. And if it's a draw, then we pass somewhere in between these two because it was just 0. And that's how this min-max algorithm is going to work. So the first time it comes in from the best move, this will be 0. Of course, there are no winners. We go to the Mixman algorithm, and it's going to, from here, we're actually going to call our results again. We're going to keep checking, and until going back to min-max, and that's going to keep increasing the player markers and going and going and going until there is a winner or there's a loser, and then it returns that value. And then when that value is returned, that's how we score this. Then we take this score and we figure out the best value that was in there based on this math that we did over here. And that in this actually is going to go to our scoring. So now we have the value, then you evaluate the best value versus the move value, and if it is a good value, then you take the rows, and that is what you pass back. So in the game, when you call this get move, it went through all of that. That's how you got these best rows and best column, and you reset it. So then then you make the game engine to make a move based on the AI, what was predicted. So that's how you basically get this. So hopefully that was a little bit of clarification on how to make this. There are other versions of this you could do. For example, if you were to actually try to run this with, let's say, let's go with 5 and 5 and play against the player. And if I go 1, 1, it's going to take a long time for the algorithm to go try to figure out what the AI move is going to be. And the reason for that is because, remember, we are iterating through every single column. So we just pick the first column, and then we simulate all the other moves to see who won, and then figure that out. And then we're going to then go to the second one and the third one, and on and on and on and on. So there's a lot of moves. As you add rows and columns, that's going to exponentially be much bigger. So there is another way of doing this, which is the Minimax algorithm with alpha beta pruning. And all that's going to say is that there are certain moves that the algorithm shouldn't make because you already know that you have the best move. And that usually will cut down on the amount of iteration that it's going to do. But as the rows and columns grow, even that might have an issue. So what are the other things you could do? Well, when you see a game like this, and it's a five in a row with 5 columns and 5 rows, you actually know and which ones should be the power moves, for example, right? So this would be probably a power move, and the reason versus this one, right? And the reason is that if I go here, actually, let's do this. So if I go here, the only way I'm going to win is if I get these rows or if I get this, 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 this. So there's only 2 ways I can win. Because if I do go diagonally, I'm not going to be able to win because it's 3, right? So I only got 2 moves to win. So this is the weakest position you can be, right? If you are over here, then you have 3 ways of winning. Going across this way, going down, and going diagonal. So this is the next power move compared to this one. And what is the third one? Well, the third one is if you're in the middle, because you can go this way, you can go diagonally this way, you can go up and down and sideways, right? So now you have more positions to go. So when you're writing an algorithm like this, you can take this into account to see where the player moved. Did they go to power positions? So you can actually, have this and can say if they went over here, that's the weakest one. Where you should go next? We're gonna go over here, which is a power move, and this will cut down. Now you have 2 columns out of the way, and that should cut down on the algorithm making all those different searches. So that's another way. And what I'm going to do is, as we do this, and I have to do some other tutorials that I would promise to do for the web APIs. I'll work on that next. But after that one, I'll see if I can get you guys another one where this will be an neural network, where it's actually we use ML.NET to train our game and then use the AI to make the moves for us by doing prediction. Okay, well, thank you so much. I'll also post the code on GitHub. It's that way you guys can download it and play around with it. Again, the code wasn't the best way to do it. At some point I'm gonna go and clean it up and make it a little bit more efficient and less code in the classes. But I'll leave that for another time and how to do refactoring again on this. Okay, thank you. Have a nice day.